Hi students, so in this video I'm wanting to use an example of a series and some inductive reasoning to figure out how to find the formula for the sum of the first n terms of an arithmetic sequence. So again, this isn't a formal proof, but we're just using some inductive reasoning, and I am using this particular example with this sum. And you'll find that these, any example that you use is going to work for this. So here's a sum of the numbers, even numbers, from 2 all the way to 54. And the neat thing about this method to find the formula is that we can use a little trick, and we can rewrite this sum backwards. So right now it's forwards, 2 through 54. We can actually write it backwards. So I'll put the last term first, and then let's keep going with that. Okay, dot, 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 and we're going to put 6 here, 4, and 2. So if we were to rewrite it backwards, we can do this really neat little thing. We can add these two rows together. And when we do that, we're going to be able to find something really interesting. Now, right now, it's hard to find the sum when everything is changing, okay? But we're going to find that when we add these two rows, we're going to get the same number every time. So look at this. If we add straight up and down here, so 2 plus 54, that's 56. 4 plus 52, that's 56. 6 plus 50, 56, right? And you're going to know we've got here 50 plus 6, that's 56 again. All of these are 56. So that's nice because that doesn't change when you add those together. When you add the left side together, you can see that we have the sum here written forward and the sum written backwards. And if you were to add those two together, you have two sums, right? You have twice the sum. So you have twice the sum, and it equals 56 a bunch of times. Now, if you want to know how many times you have a 56 here, you can actually, there's a couple of ways you can do this, but one way for this particular one is you can look right here and notice that 2 can be written as 2 times 1. 4 can be written as 2 times 2. 6 can be written as 2 times 3. And then if you go on here all the way down, 50 can be written as 2 times 25. 52 can be written as 2 times 26. And 54, 2 times 27. So it's really neat because you can actually see that we have 27 terms here. Okay? 2 times the term number. So we've got 27 terms that we're adding up. So we have 27 of these. 27 to 56 is. So if we were to rewrite this as one number here, we could say, instead of rewriting this 27 times, you can say that's 27 times 56. Okay? And now we're getting somewhere. So this is easier to find here. We have 2 times the sum. We only want to find the sum. We want 1 times the sum. So what we do is we divide both sides by 2. And then when we do that, it's really nice because then we're able to use some inductive reasoning to figure this out here. So the sum is 27 times 56 divided by 2. Now, how do we get the formula? Well, we have to think about this. So what's the number 27 represent? The number 27 actually represents the number of terms, and we can call that n. So if we're writing the formula for the sum of the first n terms of a sequence, we can say, okay, the sum is n. Okay, and then what's the 56 represent? What was the 56 again? The 56 was found when we added the first number and the last number, okay, the first term and the last term. So what we can actually do is write, okay, we know how to write that. A sub 1's the first term, and the last term is A sub n. So again, that was found by thinking about the first term and the last term added together, okay? And then we have this 2 here. And so this is the formula that you actually end up using to find the sum of the first n terms of an arithmetic sequence. And if you were to perform the same thing for a different example, you would end up getting a different sum in this case, but you would actually be able to find the same formula using it. So it's kind of neat. So we're going to use this on our next 2 examples in part 2 of our arithmetic series.